Moving on to question 8. Right, now for question 8, we can't simply make use of a cofunction. If you try that out here, let's say you break this up into sine 90 minus theta, right? You want to try and solve it the same way we did for the previous ones. We can't simply cancel sine by the left and right side, right? Essentially what we're doing is we're taking inverse on sine on both sides. But you can't do this because that too kind of messes up the whole calculation. So you can't simply inverse sine with the 2 hanging out in front like that. So we have to do something different. Okay. Here instead, I'm going to divide both sides of my equation by cos theta. Now you might look at it and like, whoa, why are we complicating this even further? But when you take a second look at it, sine over cos is actually just tan. So that becomes 2 tan. And cos divided by cos cancels itself out. So then you end up with tan theta equal to a half. Okay, so you've simplified it, the equation, which started out as two functions, sine and cos, but now it's just tan. Okay, for tan, we don't need to worry about reference angles as we've seen from before. Here we simply use the calculator to find the answer of theta. The calculator will give us 26.57 degrees, and we say plus k 180 with k an element of z. That's as easy as it gets. Let's practice this one more time. Okay, so here you see a very similar type of equation. You have sine on the one side, cos on the other side. Divide both sides by cos theta, and you are left with, in this case, tan theta on the right hand side and square root 3 on the left hand side. Okay, to solve theta, simply do the inverse of tan. All right, and our answer for this should be 60 degrees, pardon me, plus k 180, and k is an element of all integers. Okay, very simple stuff, using the tan identity to solve these equations. Now moving on to question 10. Here we have a quadratic trigonometric equation, okay, because we have sine squared theta. Right, so all that means is you can make use of the quadratic formula to solve this, or you could just factorize. I prefer factoring because it gives me practice on algebra. Okay, so we're going to do that here. The factors of 6 is 3 and 2. The factors of 1 is just 1 and 1. So there's your brackets. Now solve theta for each bracket. We'll say 3 sine theta minus 1 equal to 0, or I should say and 2 sine theta minus 1 equal to 0. For this one, I'll probably have to use a calculator because I don't know what shift sine of or inverse sine of a third is. I do, however, know what inverse sine of a half is. So that's a bit easier. I think we can start with that one first. Right, we should end up with two answers for each. So let's have a look at this one over here. For sine theta equal to a half, the reference angle should be 30 degrees. And so theta is equal to 30, or theta could also be equal to 180 minus 30 degrees. Right, that gives us the two answers of 30 degrees plus k 360 degrees, or 150 degrees plus k 360 degrees. And for this one, like I said, we'll probably have to use a calculator to find the reference angle. So I'll do shift sine of a third, and that is 19.47. So 19.47 degrees, and 180 minus 19.47 0.47. That's for the second quadrant, since sine is also positive in the second quadrant. Right, this should be equal to 160.53 degrees. Right, for both we'll write plus k 360, since this is a sine function. K is an element of z. Okay, I haven't written that anyway, so I'll write it here in the middle. Cool, done. For question number 11, we have a quadratic trigonometric equation, but we have different functions. The sine squared theta is, well, that's a sine, and then we have the cos theta. And to convert them into the same function, we have to make use of the identity that sine squared theta plus cos squared theta is equal to 1. Right? So let's remember that sine squared theta can be made the subject of the formula here. So sine squared theta is equal to 1 minus cos squared theta. And that's what we'll substitute here. 1 minus cos squared theta. Now you have a quadratic trigonometric equation that only consists of cos. And so here you can simply, I guess let's start by simplifying the equation. Okay, maybe add a couple of like terms. So I guess this 2 plus that 2 would give us a 4. And if I take it over to the other side, it should be negative 4. Okay, so then this is positive 2 squared theta minus 7 cos theta. And the positive 4 became negative 4 once we take it over. Okay, again, you can make use of the quadratic formula, but I am going to factorize because it's always good to work on those factorizing skills. Alright, so we'll put the 4 over there, the 1 over here. This one gets a minus, that one gets a plus, and then we just solve theta for both equations. Alright, 2 theta plus 1 is equal to 0, and cos theta minus 4 is equal to 0. Now this can be simplified as cos theta equal to negative a half and as cos theta equal to 4. This equation, unfortunately, when you try and find the general solution, you'll notice that you end up with no solution because if you use inverse cos of 4, well, that will just be undefined. So we'll have to continue on this side. So our reference angle will be shift cos or inverse cos of a half. Remember not to include the negative sign because you're going to use that to find the quadrants where cos is negative. Right, so cos is negative in the second quadrant. So theta would be equal to 180 minus what's our reference angle here? Is it 60 degrees? Yeah, it's 60 degrees. So theta is equal to 180 minus 60, which is 120. Then we say plus k 360. K is an element of z. Cos is also positive in the third quadrant, where we have 180 plus our reference angle. And again, this is equal to 240. We're simply going to say plus k 360 degrees. Okay, and now moving on to our last and final question. Here, we're also going to solve this one by using the tan identity. Okay, so let's start up by breaking up tan into a fraction. Now, since I'm breaking up tan into sine over cos, I might as well also split up my left hand side into sine theta over 1. Okay, when we cross multiply here, that gives us 2 sine theta times cos theta on the left hand side, and then sine theta on the right hand side. Let's now carry over the sine theta. Okay, so that's going to be minus sine theta. And then we go ahead and factor out sine theta as a common factor. Okay, this leaves us with 2 cos theta minus 1. Why did I do all of this? Well, first of all, you can't solve a trig equation that has two different kinds of functions. If you have sine and tan, you need to make them one function. Okay, it needs to either just be sine or just tan. So I changed tan into sine over cos, and I cross multiply, hoping to break it up into two separate equations where I'm just dealing with sine and just dealing with cos. Okay, and we've done so here. We can now say either sine theta is equal to 0 or 2 cos theta minus 1 is equal to 0. Okay, solving theta for both of these should give us answers as 0 and 180 degrees. Don't forget to write plus k 360 for both results. Okay, solving cos here should give us a reference angle as 60 degrees. Then since cos is also positive in the fourth quadrant, we have to do 360 minus 60, and that gives us an answer of 300 degrees. You can see how I've sort of skipped steps here towards the end, because I'm trusting that hopefully you got the pattern as we've done the previous examples. Okay, practice this method. General solution is not an easy method, right? It's sort of a long, tedious method, but it shows you that trigonometric functions can have multiple solutions. You need to practice this over and over to get good at this. There are many different scenarios, so make sure you practice all of them, and hopefully you improve. Good luck.